Okay, so this problem is asking us to solve for x. For 3 raised to the x plus 3 power equals 5 to the x power. So in order to solve this, it does take a little bit of knowledge of the natural logarithm rules, which we will be using to solve this. I'll try to explain it the best that I can, but the best way to solve problems involving natural log is just to know the properties. So hopefully seeing a walkthrough of this will help help make the properties make more sense. So the first property that we're actually going to deal with, and you can even Google natural logarithm properties, and you will get a big chart. But the best way to learn them is just memorize them and work through it. But here's the first property we'll be working with. The natural logarithm of x to the y power equals y times the natural log of x. So you'll see what happened. The y, or anything in the exponent area, will end up coming down in the front. And that's what happened here. It used to be up here, came down here. So these two statements are equivalent. So we can put this to practice right here because we have 3 to some power, just like x to some power. So if we take the natural logarithm of this, we'll end up having the natural log of 3 to the x plus 3 power, and we'll do the same thing on this side, equals the natural log of 5 to the x power. So we haven't changed anything yet. We're simply saying I'm going to take the natural log of both sides of the equation. That's where this property comes into play, because now we have something raised to the something power inside of the parentheses. So all that means is we'll take what's up at the top and bring it down. So in this case we have x plus 3 at the top. So this statement is equivalent to saying x plus 3, and that's us bringing it down, times the natural log of 3. So these two are equivalent. Equals, we'll do the same thing here. X is raised up in the exponent, so we're going to bring it down. X times the natural log of 5. So these are two equal equations. Everything about these is exactly the same, but the rules of natural logarithms allows us to write it in a different way. This makes it a little bit easier to solve. So what we're going to try to do now is basically isolate x. So we're trying to solve for x, so why don't we try to bring x all to one side. So what we'll do is we'll actually subtract both sides by x natural log of 5. We'll subtract it over here. And this will actually cancel out. X natural log 5 minus x natural log 5 cancels out. So we have 0 on this side. Now this over here, we have x plus 3 times the natural log of 3, and that's just rewriting this right here. But now we're subtracting x ln 5. So we have all of this over here, and we have the 0. What we can do is use the distribution property. We can multiply x by ln 3, and we can multiply 3 by ln 3. So it is going to expand a little, but we're still just using basic algebra properties. It just looks more intimidating. So the natural log of 3 times x is simply x times natural log of 3. There's parentheses. And now we have to multiply by positive 3 times ln 3. So we're just going to be left with 3 ln 3. So all we did was just expand this. We didn't do anything that you haven't seen before. And then we're still going to be subtracting minus x natural log 5 equals 0. So we have 3 elements here, and there's only one that doesn't include x. So what we're going to do is we're going to send it over to this side of the equation. So we'll subtract 3 ln 3 from both sides. These will cancel out. So we'll have x ln 3 minus x ln 5 equals, and we have 0 minus this value, so it's going to be a negative 3 times the natural log of 3. So what we've done now is rewrite the equation based on this rule, and we've brought x over to the left-hand side of the equation. So all we have to do is figure out what to do with these natural logs, and we'll have a value for x. So this actually brings up another very helpful rule with natural logarithms. There's a rule that says the natural log of x minus the natural log of y equals the natural log of x divided by y. So again, this doesn't force us into solving anything, but what it does is allows us to rewrite these in a way that makes it easier to solve. So I'll put a little box around that because we're going to do one more step. What you'll notice here is that we have x in both of these elements, so we're actually going to factor it out. So we're going to have x times a certain quantity equals negative 3 times natural log of 3. So if we factored in x out of this component here, we're only left with ln of 3. Same here, if we factor in x out of this, we're going to be left with a natural log of 5. So see what we did? We could redistribute it to show that it's the same, but we won't do that. Now you'll notice what we have right here is equivalent to this. We have the natural log of some value minus the natural log of some value, so we can actually rewrite this. X times some value equals negative 3 times ln 3. But now we know here that this is equivalent to ln x over y, or ln 3 over 5. So that makes it a lot easy because all we have to do is divide by this and we'll have a value for x. So if we divide both sides by the natural log of 3/5, then we'll have our answer. So let me rewrite it real quick here. So I'll move this out of the way here. So this is what we're left with, just using the rules of natural logarithms and also algebra. That's all we've used so far. So let's divide both sides by the natural log. Sorry about that. We'll divide both sides by the natural log of 3/5. These will cancel out, and we'll be left with x equals negative 3 times the natural log of 3 divided by the natural log of 3/5. It looks like in your question, and let me double check here, they are asking you to type an integer or a decimal rounded to the nearest thousandth. So what you can do if you have a scientific calculator, you can simply plug this value into your calculator, don't forget the negative, and it should give you an answer of x equals 6.45198. So if you're rounding to the nearest thousandth, that is this digit. So we're going to get 6.452 should be your answer. There we go. So again, just to summarize, all we did was basic algebra. It simply looked more complicated, but knowing the rules of natural logarithms made it a lot more easy to solve.